Hi, hello friends. Welcome back to Max Lecture Series. In our today class, we are going to understand what is called divergence, what is called rotational function, what is the difference between these two functions. When your function is defined as a divergence, when your function is defined as when your function is said to be divergence free, when your function is called rotational function, when your function is called irrotational function. There are certain things we are going to understand in our today lecture. Let us start with the first one. The first one is we are going to learn what is called divergence. In your examination, if your function will be given to you and you are requested to check whether the function is divergence or divergence free, what to do? In order to do that, first let me take the first case. We are going to discuss about divergence. That is the first topic. Let us take divergence of f is defined as, see, basically it will be represented as del of f. Now we also know in the previous lecture we already defined that del of f is simply called gradient of f. But now you are defining the same function as divergence of f. What is the difference, sir? When you are defining del of f is called gradient of f, in that situation the value of f is a simple scalar quantity. It means you can observe while calculating gradient of f, your function will not have any I vector, j vector, k vector in its expression. It will be simply represented like x square, y z, x y z, but you can't find these terms. I vector, j vector, k vector will not appear because we will be keeping our attention only with the magnitude, that is scalar quantity. Suppose if your function is expressed in terms of I, j, k like this, then that function is called vector field. See there, question itself they have identified this function is vector field because it is having certain direction, I vector, j vector, k vector. So that is the basic difference between divergence of f and gradient of f. So gradient of f means gradient, in gradient divergence in both cases del is vector, same quantity, I am using same operator only, but your function will be different. Here your function is scalar, here your function is vector. And remember one more thing, so what we understood from here, del is a vector quantity and function f is a scalar quantity. So dot product of vector and scalar, the product of vector and scalar will always give you vector quantity. You might have observed in the previous lectures we have been expressed the value of gradient of f. Resultant always vector. Vector means your resultant expressions will be expressed in terms of I, j, k only. Whereas if you observe divergence of f, in this case del is vector, of course your function f also vector. So dot product of two vector function will be in resultant, it will become scalar. Let us prove it. Already for the gradient of f we have been proved this. Let us take divergence of f. Let us estimate the resultant answer for this. So del of f. Now tell me, how will you write down this expression operator del? It can be written as dou upon dou x into I vector plus dou upon dou y into j vector plus dou upon dou z into k vector. This is the representation of operator del. Now function vector field f is defined in our question that x into I vector minus y into j vector, x into I vector minus y into j vector. That is how we are defining the operator, that is vector field f. Now tell me, what is the product of these two? We know while multiplying two vector field, that is dot product, I dot I will become 1, but all other combinations will going to be 0. Similarly j dot j will become 1, all other combinations with j will going to be 0. Similarly k dot k will become 1, all other combination with k will going to be 0. In that case, see, if you are multiplying this one with this one, then what will happen? Dou by dou x dot x plus dou by dou y dot y, rest of all are going to be 0. Now from here we know, see there, if we differentiate x with respect to x, it will become 1. Similarly y with respect to y, this will become 1. I hope, see, here it is minus y, I left that minus, don't forget this. So it will become minus y, it means here it should not be plus, it will be minus. Now tell me, what is the value of 1 minus 1? This is 0. So from this actually we understood how to calculate divergence of a vector field. But in resultant, if the divergence value will become 0, then what is the actual meaning of this? I am trying to express the resultant, I am trying to get the resultant value for divergence of f, but this resultant value will become 0. What is actual meaning? The actual meaning is, it means this function is going to be divergence free. Divergence free. This given function is not said to be a divergence function. So your resultant expression should not be equal to 0. Del, operator del dot f, this is divergence of f, it should not be equal to 0 in order to become a divergence, in order to get the divergence. So if your function is equal to 0, then that function is simply called divergence free function, or we can also call it as solenoidal. There will be alternative name for this. This function should also be called, it is also considered as solenoidal function. So what we understood from this, divergence of f should not be equal to 0, then only that function is said to be divergence. If the resultant value, while calculating divergence of f, if the resultant value is going to be 0, then that is called divergence free, or it is also called solenoidal. That's all. That is all about divergence. I hope you all understood. Very simple. Just to calculate del dot f, check whether the resultant expression is 0 or not. If it is 0, then your answer is divergence free, or we can call it as solenoidal. If it is not equal to 0, then yes, this function is divergence. That's all. Now let us learn one more thing. They also asked us to check whether this function is rotational or irrotational. What is this, sir? In order to know whether the given function is rotational or not, what we have to do is, we have to define one more function, that is called curl. So let us take the another expression, I am calling it as curl. Sir, what is the meaning of curl? That is curl f. We have to take the vector field only, but it will be defined as curl f. So whenever I am talking about solenoidal or divergence, we should take del dot f. Suppose if I am talking rotational, irrotational, curl, in that case what we have to do is same expression, but instead of putting dot, we are going to write cross. That's all. That is the only difference. In place of dot, I am going to put cross. So here I am using small f. So here also I am going to use the small f to avoid the confusion. So both are same only. I am not changing anything here. Instead of using dot, I am using cross. Sir, if cross will come, then how should I define the function? It is very easy. Let me tell you how to define the value of del cross f, vector f. So this can be defined as, take a determinant form of matrix. Just we have to find out the determinant. In the first row, we are going to arrange I vector, j vector, k vector, that is our unit vectors. In the second row, we are going to arrange our differential operators, dou by dou x, dou by dou y, dou by dou z. In the third row, we are going to put the coefficients of I vector, j vector, k vector. It is given in the vector field f. What you have to do is, take your question f here, I collect the coefficients of I vector, j vector, k vector. See, the function is actually defined as, your function f vector is actually defined as x into I vector minus y into j vector. K is not there, it means it is 0 times of k vector. Now collect the coefficient of your field, substitute here x minus y 0. After that, I hope you all know how to calculate the determinant of a matrix. So let us see how to express the resultant determinant. So this is how we are expressing del cross f. Nothing is there, just you have to, in the first row, we have to express unit vectors I vector, j vector, k vector. In the second row, our differential operators. In the third row, coefficient of vector f. It is standard, you can follow it for all type of curl functions. After that, what we are going to do now? Now let us see how to find out the determinant. I vector dot, we have to find, see, dou by dou y into 0 minus of, already in the determinant one minus will come. So in the expression itself we have minus y, cross product of this and cross product of this and this, right? After that, minus j vector. I hope you all know how to calculate the determinant of a matrix. If you don't know, just cross check our max lecture, that is calculation of determinant of a 3 cross 3 matrix, then it is very easy for you. Minus j, again I am repeating the same procedure, dou by dou x into minus y minus of dou by dou y into x. Similarly, when we are expressing it for k, so let me express it for k vector also. If you go with the k vector, then dou by dou x into minus y minus dou by dou y into x. See, when we are taking x, actually I made a small mistake here. When we are calculating, 1 minute, see there, While calculating j quantity, what will come here? This is for k quantity. I made a small mistake. J quantity means we have to calculate how it should be expressed. Dou by dou x into 0 minus dou by dou y into x. Now for k quantity, it will become dou by dou x into what you will be getting? Minus y minus of dou by dou y into dou x. Dou by dou y into x, not dou x. Okay, that's all. Now let us write down the resultant expression. See there, this term will become 0, this term will give you plus 1, minus into minus will be plus, and a differentiation y will become 1. So I can say this is I vector. 1 minute, yeah, this will become simply I vector. Okay sir, this is fine. After that, what we have to do? If you observe the second case, so first one is right? Yeah, it is correct. Second, if you go with j, what will happen? This total term will become 0. Yes, so this total term will become 0 minus j. Now if you go with the last expression, this total term also will become 0. So this is how we are identifying the resultant expression. So finally what we got, when the moment we are estimating curl, so what we found, this term is going to be 0. 1 minute, actually I made one more mistake here. This is dou x, dou y, dou z. In that case what will happen, this will be z, this is not sorry guys, this is not y. See, this is how we are making the mistake, how I made the mistake. Just correct it yourself. Here we have to keep dou by dou x, dou by dou y, dou by dou z. So here it should become what? It should be expressed dou z. In the sense, if you are differentiating y with respect to z, that will also will become 0. So the complete value will become 0 here. What we found here, we have been tried to calculate the value of del cross f, but that is also become 0. What is the actual meaning of this? If the value of del cross f will become 0, then that function is called irrotational function. Then that function is called irrotational function. That's all. I hope you all understand this. This will be simply called irrotational function. Suppose if the value of del cross f will not be equal to 0, then only that function is called rotational function. Then only that function is called rotational function. So the difference between irrotational and rotational, always we are trying to cross check whether the function is rotational or irrotational with the help of del cross f, that is curl of a vector field. So while calculating the curl of a vector field, see, in case of curl, both are vector only, but resultant also going to be vector only. Remember this, in dot product, two vector field will resultant yields to what? Scalar. When we are multiplying two vector field in dot product, resultant will become scalar. But when the moment you are expressing the value of curl, resultant also will become vector only. And one more thing is what? Del cross f should be not equal to 0 in order to define that the function is rotational. If it is going to be equal to 0, then that function will be treated as irrotational function. That's all. I hope you all got the clear picture about that is a difference between divergence and curl. If you don't understand, no issues. One more time watch the lecture. Even in the upcoming lectures also, we will be going to solve this kind of problems again and again. So you will be getting the clear idea. This is all for this lecture. Rest of things we will see in the next class. Thank you all.